Alright, so today our goal is to talk a little bit about graphing and statistics. So in biology and science in general, graphing is a big part. Throughout the year, we're going to look at various different graphs, and we'll be throwing out statistics, and I want you guys to understand how to read a graph, how to create your own graph to reflect data that you get when you do experiments, as well as how to actually represent your data as a statistic. So, the importance of a graph is it can provide a lot of information in one space. So, you do an experiment, you get a lot of data, you can put it right in a graph, and someone can just take a glance at the graph and they can get a lot of information just by glancing at it. It's a very easy way to represent all the information that you have, but you don't need a lot of words to explain it. So it's easy on you, as in you don't have to write as much, but it's also easy on the person that's viewing it and trying to understand the data that you've collected, because all they have to do is glance and they can get a general idea of what you're trying to express. So graphs themselves are used to show trends in data. So when you look at a graph, you see it's generally increasing, it's decreasing, or maybe it increases and then decreases. And you can kind of get an idea of a trend. And that could be over time, it could be over seasons. Whereas a table is used to show like an exact value. So a graph is good to show a trend, a general what happens over time, what happens, just general trends, increasing, decreasing, going up, going down, leveling out. But a table shows you exact number values. So we're going to look at the different types of graphs you might see this year. The first one I'm sure you guys have seen before is called a pie chart. Pie charts a lot of times are used for percentages to show parts of a whole. So if you look here, this says Buck Creek watershed land use. So you could say over half of the water here is going to, that says agricultural, which means growing plants. We can see very small percent is used for nothing at all. The blue is transportation. This one here is for residential, where people live. So you can just kind of get a glance and get an idea of the parts of a whole, or percentages here from a pie chart. The second one is a bar graph. Lots of students love bar graphs. Sometimes we can use bar graphs way too much. And this can show either horizontal or vertical bars, and it's used to compare information. So if we're saying ice cream sales by flavor, at a glance, most people buy chocolate, followed by vanilla. And people don't seem to like this one down here. That's garlic, which, yeah, who would like garlic? Garlic ice cream. So again, nice, easy visual representation of what we're trying to show, and you can compare across the board. The most common type of graph that you're going to see in biology is going to be the line graph. And I encourage you to use a line graph anytime, unless it specifically says use another type of graph. Typically, if I'm going to ask you to make a graph, it's going to be a line graph. So you're going to want to use line graphs, and these show change over time. So this one shows data over years. It could be months, it could be days, but it's always typically change over time. And these are plotted against a x-axis or a horizontal axis and a y-axis. And when you are graphing data, so once you create a chart, you can use this chart to create a graph. One thing that you'll need to know for charts is the left side here. This one is always going to go on the X, and your right side is always going to appear on the Y-axis. Typically also, the left side here, year in this case, is going to be the independent variable, And the right side of your graph here, this is number of species. This is going to be your dependent variable. So if you're graphing results you get in an experiment, this side is going to be the independent variable, and this is the dependent variable. So when you're actually looking at the graph itself, this is the x at the bottom, horizontal, and the one going up and down, vertical, is the y-axis. And when you're creating your graph, your goal is to get all this information here in this chart into this graph so it's easy to read. However, you need to be, there are many steps you have to take to make your graph perfect. You need to have a title, because otherwise someone's just going to look at it and be like, oh, what is this graph even trying to say? So you want to be specific with your title. So if I'm looking at if the amount of water affects plant growth, I could say something about how changes in amount of water affect plant growth. You want to be very specific, and typically your title of your graph is going to have your independent and dependent variable. The next thing that you want to do after you have your title is actually label your independent variable. So it could be, maybe I'm doing water and growth of my plant. I'm labeling it. So water, I'm going to measure in milliliters. I want to be as specific as possible. And growth, I'm going to measure in centimeters, let's say. So you want to be sure you always include your units on both your independent and dependent variables that you're going to put on your graph. The next step in setting up your graph is going to be to make a scale. One thing I do want to note about your scale is you do not always have to start from 0. So it doesn't always have to start with 0. If you're working with a number set and all your numbers are in the upper hundreds, start with 100. So it doesn't really matter where you start, but you need to keep it consistent. So you need to make sure you adequately space things out. You don't want things to be too crunched together. You want to spread them out, and you want it to be proper scale for your data. So if I have numbers that I'm graphing from 0 to 4, let's say, I don't want my numbers to go all the way up to 100. I want to keep it in the range of the data that I'm graphing. So you want to be sure that you set up an appropriate scale. The next thing you're going to do, you want to be sure you're actually going to put your information on your graph. Just note, you have to put all your information on there. So again, make sure that your scale fits appropriately so you can get all of your data points on there. Oftentimes, if you are creating a line graph, you're going to see sometimes you'll have these points. And instead of just connecting the points, you see a straight line drawn through them. That's called the line of best fit, meaning on average, this is the trend that that line takes. So it's just an average amongst all of the points to make a one straight linear line. And it's called the line of best fit. All right, if you wanted to practice, you can, here's a data set. You can pause the video and go ahead and practice making a graph based on this data. So go ahead and pause and create a graph based on that data. All right, there is some vocab that you're going to need to know along with graphing, things that you'll see regularly. So you may see this word interval. Intervals are just the space between the values on the x and the y. So if you're putting a number for every 2, so if you're going 2, 4, 6, your interval is going to be 2, the space between the values on your x and your y. One word, this is going to be the most important word because you're going to see this over and over and over and over all year. That is called optimum. Optimum means the best, the most, the highest. The way I like to refer to this when people are like, I've never heard of Optimum, but I've heard of Optimus Prime. Optimus Prime, he was the best. So it is the best or the highest point on your graph. Another word that you might hear is abundant. Abundant just means there's a lot of it. It's really common. So, for instance, you could say there was an abundance of water, lots and lots of water. Another word that you might hear is rate or slope. And that's just referring to how fast or how slow your graph increases. All right, some statistical analysis. So looking at the actual numbers that you're going to place on your graph. Some things that you might do with those numbers is find the mean. The mean is a fancy way of saying average. So what is the average of the numbers? And the way that you do that is you add them all up and then divide by how many there are. So for this one here, you add 2 plus 4 plus 3 plus 2 plus 4 plus 3, and you divide by 1, 2, 3, 4, 5, 6. So let's just pause, take a second to fill that one out. I'm going to go ahead and do it on my calculator here. So 2 plus 4 plus 3 plus 2 plus 4 plus 3 equals. So I added them up and I got 18. So I added them up and I got 18, and I'm going to divide by how many there are, and there are 1, 2, 3, 4, 5, 6. So then you take 18, you divide by 6, and that gives you the average of 3. The next thing you might do with your numbers is find the median. The median is a way of saying the middle value in your data set. So what you're going to do is you're going to put your numbers in order. And typically you arrange them from smallest to largest. However, you can also do the other way around. It doesn't matter as long as they're in the right order. But I feel like the easiest way to do this one is going to be just to go ahead and put them in order. So let's just take a second. My smallest number here is 1, followed by 3. I have 2 3s. I like to mark them out as I go because it makes me certain that I got all of them. I have 3 of the number 4s. And then a 6, 7, 2 8s, and a 9. 2 8s, and then a 9. Now what I'm going to do is I'm going to find which number is in the middle, and the easiest way to do that is by just marking them off on each side. So I cross out 1 at the beginning and 1 at the end, and I keep going with that until I have 1 left in the middle. So for this one, the median is 4. However, that brings you to a problem. Sometimes when you're doing this, you could, if I had 1 more number in this set, I would have been left with 2 in the middle, and I wouldn't have had 1 perfectly in the middle. If you are left with 2 in the middle, you're just going to average them out. You're going to add them up and divide by 2, and then that will be your median. Okay? The next one is mode. MO stands for which one shows up the most often. So which number do you see most often in your number set? And because I already lined them up, I just say I had 1 of these, 2 of these, 3 of these. 1, 1, 2, 1. So I know the number that showed up the most often in my data set was 4. So the number 4 was there 3 times. Therefore, the one that showed up the most often was 4. Okay, the last thing you might do with your information is find the range of your information. The range of your information is going to be the difference between the largest number and the smallest number. So my numbers range from 1 to 100, or the grades in this class range from an 85 to 100. That's your range. It's the difference between the largest number and the smallest number. So what you're going to do is you're going to find the largest. So if we're looking at this set here, the largest number I have there is 8. The smallest number I have in this set is 1. And to figure out the difference between them, I just subtract the smallest number from the largest number, and I'm left with a range of 7. So in this case, my range is 7. All right, so after this, if you go onto Canvas, you're going to have a bit more practice doing some statistics and graphing.